Let's just dive right into it. Welcome to today's explainer. I'm absolutely thrilled you're here because we're tackling what a lot of people consider to be a massive puzzle in medical coding, decoding the ICD-10-PCS manual for cranial and brain procedures. Look, reading operative reports for neurosurgery can totally feel like deciphering an alien language. But stick with me, because by the end of this, you're going to have the exact tools you need to map out these codes with total confidence.
I mean, think about it for a second. How do you even begin to translate something as mind-bogglingly complex as brain surgery into a single alphanumerical code? It sounds literally impossible, right? But here's the secret. The ICD-10-PCS manual isn't just a boring list. It's actually a highly detailed, incredibly logical geographical map. And today, we're going to learn how to read that map together, translating anatomical locations and surgical actions into precise character values. So here's our decoder's map for today. First, we've got cranial anatomy mapping. Second, surgical interventions. Third, imaging and radiation. And fourth, new technology and therapies. All right, let's jump straight into Section 1, cranial anatomy mapping.
Now, I want to completely validate what you're probably already feeling. ICD-10-PCS coding for the cranial cavity is, well, it's complicated. You might be navigating the medical and surgical section 1 minute, and then suddenly you find yourself in administration, imaging, or even new technology. It's a lot. But mastering the specific body part values, that is the absolute master key that unlocks the entire map.
It's actually really interesting how broad anatomical terms get funneled down into single characters. In the medical and surgical section, if a table only gives you a general term, you just use that as your default. Take the entire brain, for instance. That's represented by the value 0. And that 0 includes the encephalon, the cerebrum, and the corpus callosum. But then, look at the precision you can tap into if you need it. The cerebral meninges get a 1, a specific cerebral hemisphere gets a 7, and the cerebellum gets a C. Honestly, the manual's appendices are going to be your absolute best friend here for figuring out exactly which tissue falls under which value.
Let's see how this logic builds as we go even deeper into the brain. Deep structures and nerves actually have their own specific values. You've got the basal ganglia at 8, the thalamus at 9, and the hypothalamus at A. But I want you to pay special attention to those numbered cranial nerves. The vagus nerve is Q, and the accessory nerve is R. The crucial thing to remember here is that these specific nerves stretch way out from the brain into the abdomen or the spinal root. Because of that, they're coded with absolutely no indication of where the procedure actually took place. Whether the surgeon was working inside or outside the brain, it's just simply Q or R.
So what happens when a surgeon operates on some tiny nerve branch that isn't even listed in the manual? Well, guideline B4.2 basically saves the day here. It tells us that the procedure is coded to the closest proximal branch that actually has a specific body part value. Think of it like this. If a procedure targets the mandibular branch of the trigeminal nerve, and that doesn't have its own code, you just trace it back to the main trigeminal nerve. That gives you the body part value K. Make sense?
We also have to make a choice between two core body systems when we're looking at the medical and surgical section. For highly specific brain tissue, we go with the central nervous system and cranial nerves. That's our 0. But for more general approaches, we use anatomical regions, general, which is W. Now, why does W matter? Well, picture a neurosurgeon drilling a small borehole into the skull to relieve pressure or just to get access to the brain. Creating that borehole is an approach, it's not the final procedure itself. So for that, you'd report from the W anatomical region section, using cranial cavity 1 and a percutaneous approach 3, depending on whether they're doing drainage, extirpation, or some other root operation.
Moving right along, let's hit Section 2, surgical interventions.
Bypasses are incredibly common in neurological coding, whether you're restoring mobility for paralyzed individuals or treating something like hydrocephalus. And this perfectly illustrates the built-in logic of the ICD-10-PCS system. Guideline B3.6a tells us we have to identify the body part bypassed from using the 4th character, and the body part bypassed to using the 7th character. That 7th character is our qualifier. Just looking at these diverse qualifier values for the to location, you can really see how fluid the logic is here. If a flexible tube is implanted to drain excess cerebrospinal fluid for hydrocephalus, you're usually shunting that fluid from the cerebral ventricle in the brain straight to the abdomen. So your from body part is the cerebral ventricle, which gives us a 6, and your to qualifier is the peritoneal cavity, which, conveniently, is also 6. You're literally just following the fluid's path. Another super common intervention is inserting neurostimulators to treat conditions like Parkinson's disease, tremors, or epilepsy. Now, this one's a little tricky because it actually requires 2 separate codes. Why? Because it's a two-part system. Step 1 is coding the battery-powered pulse generator that gets placed under the skin. That one comes from the subcutaneous tissue body system, which is J. Step 2 is coding the actual leads, or the wires, that are placed up in the brain. That part comes from the central nervous system, O, using the device value M for neurostimulator lead. Of course, sometimes the intervention is less about moving fluid or electricity and more about mapping. Table 00K actually includes body part values for mapping procedures in the brain, thalamus, and cerebellum. If you're reading an operative report and it mentions finding connectivity problems, like the kind they study in autism, they might be using something called connectomic analysis. This is a really advanced technique that maps the location and direction of white matter bundles in the brain. To code this in table 00K, you'd use qualifier 1 to pinpoint this specific type of analysis.
All right, let's shift gears to section 3, imaging and radiation.
So instead of being lumped into the medical and surgical section, these procedures actually have their own dedicated homes. Imaging is going to be in section B, and that covers your standard CT scans and MRIs. Nuclear medicine is section C. That's used when unsealed radioactive substances are used to diagnose conditions like Alzheimer's, using root operations like PET imaging. And then we have section D for radiation therapy. This deals with encapsulated radionuclides used to treat cancer, using operations like beam radiation or brachytherapy.
Let's zoom in on brachytherapy for a second. Basically, this is a procedure where a solid radioactive substance is placed directly inside the body, right near a tumor. In the radiation therapy section, it is always reported with the modality value 1. But, fair warning, the coding guidelines around it are quite multi-layered. It all depends on the timing and the exact element being used. Here's how it works. If the radioactive element stays in the body permanently after the procedure, you're usually going to need 2 codes. Step 1 is grabbing a code from the insertion table, OOH, for actually placing the radioactive element. Step 2 is getting a code from the radiation therapy table, D00, to specify the modality and the isotope. But wait, there is a pretty notable exception. If the surgeon uses cesium-141 or palladium-103 collagen implants, you actually only need the code from table OOH. That's because those specific device values are only found in that table. Timing totally dictates your coding path here too. Let's say a temporary applicator is inserted for the later delivery of brachytherapy. You code that initial insertion from table 00H using device Y for other device. You'll worry about coding the actual therapy later when it happens. But if the insertion of the applicator and the treatment both happen in the exact same session, you only report a single code from the radiation therapy section, just the one.
And finally, we've made it to section 4, new technology and therapies.
The absolute bleeding edge of neurological treatments lives right here in section X. And the crucial point to remember is that section X doesn't just stick to one body system. Brain procedures here are actually split across 3 different body system values. You've got the nervous system at 0, anatomical regions at W, and physiological systems at X. You really have to pay close attention to the specific technology being used so you know exactly which system to select.
To give you an idea of how granular these breakthroughs get, here are a few examples. Focused ultrasound therapy for cancer, which uses low-intensity ultrasound alongside a chemical agent, is coded under nervous system. The root operation is destruction, value 5. Meanwhile, if they're using computer-aided detection to monitor the brain's electrical activity, that goes under physiological systems, root operation monitoring, value 2. Or if they're using a non-contrast CT to assess intracranial vascular activity for something like obstructive hydrocephalus, that's root operation measurement, value E. It's incredibly specific.
Let's look at one highly specific example of just how incredibly modern this manual gets. It's a mouthful, Eladocagene XU parvicovec. This is an advanced gene therapy used to treat a very specific deficiency. To code this, you'd head over to section X, use the anatomical region body system W, root operation introduction 0, body part cranial cavity and brain Q, and the device or substance value 1. It's so precise, and it perfectly captures a therapy that literally didn't even exist just a few years ago. How cool is that?
And just like that, that brings us to the end of our decoding journey. We've mapped out the deep brain structures, we've connected the logical paths of surgical bypasses, navigated all those tricky radiation timing rules, and even touched on some state-of-the-art gene therapies. The manual is complex, for sure, but as you've seen, it's also entirely logical once you know how to read it. So here's my question for you. With this map in your hands, how will you decode the complexities of your next cranial operative report? I really hope you feel totally equipped to tackle it head on. Thanks so much for learning with me today in this explainer, and keep exploring.